Dear students, good morning. We are going to start Unit 2. In Unit 1, we have discussed how to calculate composition of the gaseous mixers and also composition of the solutions. And also we have discussed in the beginning of the Unit 1 units and conversions. Now in Unit 2, we are going to discuss vapor pressures of the solutions, etc. That means when a solution is in contact with its vapor phase, how to calculate the total pressure and vapor composition. In order to calculate these things, first we need to discuss about Raoults Law. So Raoults Law we will discuss now. So first of all, these solutions, any solution you take, depending on its temperature, it exerts some pressure. Any solution, depending on temperature, it exerts some pressure. That pressure is called vapor pressure of liquid. Vapor pressure of the liquid. That is vapor pressure of water, like that we say, which is denoted by capital P. Vapor pressure of liquid denoted by capital P. So this vapor pressure of liquids depends on temperature. Depends on temperature. As T increases, Vp increases. As temperature increases, vapor pressure also increases. Usually in the problems what we are going to solve, vapor pressure data is available. Vapor pressure data is available in literature for different liquids. And at different temperatures. Okay, so usually Vp data will be given in the problem. So this is the term we have seen first about the vapor pressure of the liquid. Now we will see, we will discuss Raoults Law. We will discuss Raoults Law. To discuss Raoults Law, you just consider a solution. Containing three components A, B and C. Initially we are given with this solution, and this solution is at a temperature of T and at a pressure of Pt. Now depending on this temperature T, each component A, B and C, every component will evaporate and forms its vapor phase. That is, this is vapor phase. And how this vapor phase is formed? Depending on temperature T, each component will evaporate. For example, component A will evaporate here and it occupies the vapor space, and immediately it exerts pressure that we denote it as PA, partial pressure of A. Any vapor content will exert some pressure over the surface of the liquid. So in the same way, B also will evaporate and exerts its partial pressure, which is denoted by B. And C also will evaporate and exerts its partial pressure Pc. Now, two terms we are going to see here, that is liquid composition and vapor composition. Two terms we are going to discuss. This is the liquid we are having. and we only prepare the solutions, so we know the composition of the liquid. So let this composition is XA, XB and XC. That means XA is equal to mole fraction, XA equal to mole fraction of A in solution or in liquid, whatever it is. Mole fraction of A in a solution, and XB is equal to mole fraction of B in a liquid or solution. Then XC is equal to mole fraction of C. So this is called liquid mole fraction. This is called liquid mole fraction. Liquid composition, you can say. This is a liquid composition. So XA, XB, XC. Then another term we want to see. So liquid composition is what? XA, XB, XC. Then another term that is here, vapor composition. Vapor composition. After the vapor phase is formed, here you will have some amount of A which is represented by Ya, and here Yb, and here Yc. So your vapor composition is Ya, Yb, Yc. That means here Ya is equal to mole fraction of A in vapor phase, and Yb is equal to mole fraction of B in vapor phase, and Yc is equal to mole fraction of C in vapor phase. So this is vapor composition. Okay. So we are given a liquid with components A, B, C, and the composition is represented by XA, XB and XC. X is the mole fraction in the liquid phase. This is mole fraction. Okay. Here Ya, Yb, Yc are the vapor composition. That is also mole fraction only. And what is Pa, Pb, Pc? Partial pressure of A exerted here. Pa is equal to partial pressure of A, and Pb is equal to partial pressure of B, and Pc is equal to partial pressure of C. This is the notation we have. Next we will try to apply the Raoults law. We will try to discuss what is Raoults law. Here you take one example in this ABC. Suppose A is 80% and B is 5%, and this is mole percent only, and 85, that C is remaining 15% C. Suppose this solution is having this mole percent A, B, C. Now what you can understand from this? Which Pa will be more, or Pb will be more, or Pc will be more? For this case, it is very clear that Pa will be more, because A is present in a large quantity. That is, A is 80%. 80% of this solution is A, large quantity. That is why Pa will be more here. So Pa is more in this case. Pa is more. Okay. Now, which one is less? Pb is less, is least, you can say. Pb is least here because it is present in very less quantity. In between here Pc. So like that. From this, what you are understanding? Partial pressure Pa is directly proportional to its liquid mole fraction. This is liquid mole fraction, no? This is liquid mole percent or mole fraction, whatever it is. So this we can say. Partial pressure of A is directly proportional to its mole fraction in the liquid phase. X is always used, small x is always used to indicate liquid mole fraction, small y is always used to indicate mole fraction in the vapor phase. Throughout our subject, same notation we use. So, partial pressure exerted is directly proportional to liquid mole fraction. If this is high, partial pressure will also high. So, PA is directly proportional to XA. So, to take away this proportionality constant we will introduce, that is PA is equal to XA. This is Raoult's law. This is Raoult's law. Then what is this PA? Vapor pressure of A in a pure state. Vapor pressure of A in a pure state. Okay. So what is Raoult's law? Partial pressure of A when A is in a mixer is one component. If you want to write for B, we write PB equal to PB into XB. So partial pressure of A is equal to vapor pressure of A in pure state into liquid mole fraction. This is Raoult's law. So here usually in solving the problems, XA composition will be given XA and this also will be given vapor pressure as data only. We can calculate PA. Partial pressure of any component we can calculate. This is Raoult's law. Then how to apply this Raoult's law? And also we club Dalton's law to calculate total pressure and vapor composition. In this you can also see, suppose here there is no B and C, only A is there. Then we say pure liquid, isn't it? Then XA is equal to 1. So when XA is equal to 1, then vapor pressure is equal to partial pressure. There is no difference between partial pressure. We don't use partial pressure term when there is no mixer only. So in the pure state, we don't have only partial pressure, only vapor pressure. So in this we have seen now what is Raoult's law, and also we know Dalton's law. In this you are going to solve problems where you will have two questions. First question is calculate total pressure of vapor phase. Total pressure of this vapor phase. So this vapor phase is formed out of this solution depending on this temperature. This vapor phase is formed out of this solution depending on this temperature. Then how to calculate this total pressure? That is the first question. Then also calculate vapor composition. Also calculate vapor composition. This is the second question. So these are the two bits you will have in the future problems. So what is calculate the total pressure means here in this vapor phase what is PT, and calculate vapor composition means what is the vapor composition? This is vapor composition. So YA, YB, YC, how much you need to calculate. So we will discuss then how to calculate these two questions. First one, calculate total pressure of this vapor phase. Total pressure over this surface, we can say. This is vapor phase means over the surface. Total pressure over the surface. So what is total pressure? PT equal to PA plus PB plus PC. That is Raoult. Dalton's law. PB plus PC. This is Dalton's law. So you can calculate total pressure here if you can calculate partial pressure of A, partial pressure of B and partial pressure of C. So we should see now how to calculate PA, PB and PC. So how to calculate PA, PB and PC? We can use Raoult's law. So use Raoult's law like this. Calculate, use this. PA equal to PA into XA. XA will be given in the problem. Vapor pressure in the pure state of component A will also be given. So you can calculate PA. So like this you can calculate PA. Similarly, you can calculate PB equal to PB XB, PC is equal to PC XC. You can calculate all the three. Then PT equal to PA plus PB plus PC. Okay. So you can calculate like this the total pressure of the system. The next part, the second part is calculation of vapor composition. Calculation of vapor composition. That is the second part, how to calculate. So numerically we will solve in the problems. Now theoretically we are discussing. Calculation of vapor composition is nothing but YA is how much, YB is how much and YC is how much. That is calculation of vapor composition. This is vapor composition, YA, YB, YC. Then how to calculate this? We have to use both Raoult's law and Dalton's law here. According to Raoult's law, what is PA? PA is equal to PA XA. This is Raoult's law. And Dalton's law, according to Dalton's law, PA is equal to PT YA. This is Dalton's law. We know these two. Throughout our problems of this topic, we are going to use these two equations. So what you need? You need YA. So here YA is equal to what now? PA by PT. That is from Dalton's law you can write PA by PT. You already calculated PA here. You calculated PA. PA equal to PA into XA. So you see the difference between writing of partial pressure and vapor pressure. Here this is capital P. Here this is small p. So we can calculate YA using this PA by PT. PA is already calculated here and PT is also already calculated. In other words, PA equal to PA XA. This is what? Nothing but Raoult's law. It is Raoult's law. This is what? Dalton's law. So using Dalton's law we calculate YA equal to PA by PT. PA we calculate using Raoult's law. So this PA XA by PT. So on the whole you can say YA equal to PA XA by PT. This is vapor pressure. Okay. Similarly, YB equal to PB XB by PT and YC is equal to PC XC by PT. or YCB right here. This is YB and YC is equal to PC XC by PT. Like this you can calculate YA, YB and YC. This is nothing but partial pressure, already we calculated here. This is PA and this is a PB and this is a PC. Okay, so here we have seen how to calculate total pressure and the vapor composition when a solution is in contact with its vapor phase. When a solution is in contact with its vapor phase, how to calculate total pressure and vapor composition we have discussed. Next class we will solve the problem. Same thing, numerically we will solve. Thank you.